Welcome back. We're continuing to look at piecewise defined functions. In our last video, we looked at how to evaluate a piecewise defined function at specific input values. And now we are going to look at how to graph a piecewise defined function on using that same idea of the different inputs. So if we look at this, we are going to go back to this function. And we had three different domain sections. And if an x value fell into the b, we applied the b rule. If an x value fell into the a range, we used the a rule. So we have domains and their associated rules. And that's what we are going to set up with our table here. So I see I have three different domains. So I am going to call this A, B, and C. And I am going to divide my t-table up into three regions. So this is my A region, my B region, and my C region. The first thing I want to do is turn my paper sideways, and I am going to write my domains of these on the left side here. So my first domain I have here is x is less than or equal to -2. Then I have -2 is less than x is less than 3. And then I have x is greater than or equal to 4. So I have my A domain, my B domain, and my C domain. Over on the other side, I'm going to write the rule that goes with each of those domains. So the rule that goes with my A domain is y is equal to -2. The rule that goes with my B domain is y is equal to 2x minus 3. And the rule that goes with my C domain is y is equal to 1. I'm going to turn my paper back vertical. And now what I'm going to do is I am going to write values that meet this domain. And I'm always going to include the boundary. So my boundary here is -2. And then I'm going to include values that would also make this true. So that's going to be like -3 and -4. If I were to draw, if this were a number line, -2 would have a closed circle, and it would pass through -3 and -4 for my domain if I were graphing that domain on a number line. So now I'm going to take these values and evaluate them for this rule. And the rule is just y is equal to -2. So I'm going to have -2, -2, -2. So now I am going to graph this. You can see that -2 is included in my domain. So what that means is all the values up to and including -2 will follow this rule. So what I have drawn here is essentially what I'm going to draw on my paper. But I'm first going to start by plotting these ordered pairs. So I have the ordered pair -2, -2. I'm going to plot that with a closed circle because that's what's here. And then at -3, -2, I'm going to put a dot, and -4, -2, I'm also going to put a dot. And then I'm going to connect this, and the line is going to look just like this, but kind of rotated. So I've got a closed circle and an arrow over here. That is my A region of the graph. I'm just going to write an A next to it so I can kind of keep track of it. The next thing I'm going to do is I'm going to graph this middle chunk, the B portion. So I'm again going to include both of my boundaries. So my boundaries are -2 and 3. A number that is in between these is 0. And if I turn this paper on its side, if this were a number line and I were graphing it, there would be an open circle at -2, an open circle at 3, and a line in between because I have a less than and a less than. So -2 and +3 are not included. everything up to, but not including that value is. Okay, so now I am going to go about evaluating these based on my rule. So this is going to be 2 times negative 2 minus 3. So that's negative 7. At 0, I'm going to have 2 times 0 minus 3. That's going to be negative 3. And at 3, I'm going to have 2 times 3 minus 3, which will be 3. I'm now going to graph this. So I have negative 2, negative 7, negative 2, 1, 2, 3, 4, 5, 6, 7. And I'm plotting that with an open circle because that's what's next to it. Because I have in the domain, negative 2 is not actually included, but it's almost included. It's my boundary. Then I'm going to plot 0, negative 3 as a dot. And then I'm going to plot 3, 3 as an open circle because, again, 3 is not included, but it's almost included. And I am going to connect this with a line. And again, what you'll notice is it looks just like what I graphed over here, what my domain would look like if I were to graph it on a number line, but at an angle. It's just been rotated. And now I'm going to go through my part C, which is my last chunk, which is x is greater than or equal to 4. So my boundary there is 4. It also passes through, like a number bigger than 4 is 5 and 6. Turning my paper on its side, 4 would get a shaded circle, and it would pass through 4, 5, 6 and go all the way up to infinity. Okay, so graphing this, I'm following this rule, which is just 1. So 1, 2, 3, 4, 1 is going to get a shaded circle because its x is greater than or equal to 4. So 4 is included. And then 1, 1. So that is a horizontal line. The next thing I want to do with this is come through and figure out what my domain is and what my range is. So in order to identify my domain, I am going to draw a second x-axis down below this. And I'm going to mark all of the key spots. So negative 2 was a key spot. I always mark 0. 3 was a key spot, and 4 was a key spot. And when I'm talking key spots, I'm looking at my boundaries. So negative 2 is a boundary, negative 2 is a boundary, 3 is a boundary, 4 is a boundary, and I always want to just include 0. So now what I'm going to do is I am going to graph my domain. So I had x is less than or equal to 2. So that's a shaded circle, shading to the left. Okay. Negative 2, so that's an open circle at negative 2, open circle at 3, shading. X is greater than or equal to 4, shaded circle at 4, shading to the right. And if we were to look at this, if you were to project a light, this is where the shadow would be, right? So x values, there is a x value graphed for each of these values all the way along. So if I look at this and I write this in interval notation, my domain is really, so it starts at negative infinity, which is a soft bracket, and we shade all the way up to 3, but not including 3. We jump over a section. We start shading at 4, and we shade all the way up to positive infinity. So this is my domain. I'm going to go through a similar process for my range, and I'm actually going to turn my paper on its side to do this. So I have a line, and just like before, I'm going to mark all of my boundaries. Okay, so I see there's a boundary down here, so let's see what that one is. That's going to be negative 7. So negative 7 is the boundary here. So this point is negative 2, negative 7. All right, so then this is a key point. That's negative 2. I always mark 0. This one's at 1, and this one's at 3. Okay, now I'm going to shade for each of these. So for A, A only has graphing at y values of -2. For B, I have an open circle at -7 and an open circle at 3 and shading in between. And for C, I only have shading at -1. So if I look at this, so I'm now going to use that and I'm going to write in interval notation my range. My range is from -7, not included, all the way up to 3, not included. So I've now found both my domain and my range, as well as graphing this function.